So it doesn't help to just take all of your vitamin C at once. That's why it's important to eat balanced meals throughout the day. You need to be getting a constant supply of these water-soluble vitamins. The same is for folic acid. You can't just take it once a month. You need to be taking it regularly in order that you keep the stores up in your body. Otherwise, you're going to excrete it. You're going to get rid of it very quickly. In contrast, if we think about vitamin A, is this going to be water-soluble or fat-soluble? Yep, so this is a fat-soluble vitamin. Vitamin E is another big one that's fat-soluble, that gets a lot of press in terms of being an important vitamin to take. We can think about what it means when a vitamin is fat-soluble instead of water-soluble. Well, now it's not going to get excreted out of our body so quickly, so we actually can build up amounts of vitamin A or vitamin E, for example. But that can also pose a problem if you think about biologically what's happening. And up here, I just showed 2 different supplements that I found on the internet. This is a one-a-day vitamin. It has about 100% of what you need of everything. And then this vitamin is one that I found that's supposed to really help you with your eye health. If you have bad vision instead of glasses, they suggest that you try this vitamin here. And what you can see is that it has 5 times your daily value of vitamin A and 13 times what you need of vitamin E. Is this a good idea? No. Basically, you are just building up more and more and more of these fat-soluble vitamins into your body. And there have been studies that have come out recently trying to look at the health benefits of vitamin E. And in some of these studies, they give these mega doses. And instead, what they find is increased bleeding in these patients, an increase in overall different types of death that can be happening. You want to take your vitamins, it's very important, but you don't want to just build up, and you want to think about, is the vitamin that I'm going and getting 800 times what I need a day, is that a water-soluble vitamin or a fat-soluble vitamin? And using your chemistry, you should be able to very quickly take a quick look at that structure and figure out what kind of a vitamin that is. All right, so that's just one reason we would want to be able to think about polarity, is thinking about whether something is very water-soluble or not. Let's think about some other things that have to do with polarity and then can tell us a lot of other information. So let's move on to talking about the shapes of molecules. And the shapes of molecules is very important for a number of different properties when we're thinking about chemical reactions and reactions that take place in the body. When we talk about shapes of molecules, we're talking about the geometry of that molecule. And the geometry influences all of its different properties, including things like melting point or boiling point, its reactivity. We just saw when talking about polar molecules that it influences whether or not the molecule itself is polar or apolar. It's also really important when we talk about biology. Shape is particularly important when you think about enzymes having an active site where a molecule needs to fit perfectly into the active site. It does that because of its shape. A quick example that we can think about is with sucrose. Does anyone know what sucrose is? It's just table sugar. Sucrose is that crystalline sugar that we hopefully use in most of our sugar intake as sweeteners. A lot of times we use corn syrup, which is often not sucrose, and which tends to be not always as good for us, though anything in too much excess is obviously a non-ideal situation. But in order for us to use the energy from sucrose, sucrose is made up of 2 individual sugar monomers. It's made up of a monomer of glucose and one of fructose, a 6 and a 5-membered ring. So in order for our body to use it, we need to break it into its monomers. And if we do that, we can do it by what's called hydrolysis. Sucrose in water breaks down into its 2 monomers. Now our body can use it.